Alright, this is purple problem number 3. So we have a cannonball fired at 30 degrees above the horizontal, travels in the air for 1.84 seconds, and then we want to find the initial speed. So making our table, we got a delta x of 28.6 meters, a velocity in the x direction of we don't know. We got a time in the x direction of 1.84 seconds. We do not know our overall v initial, that's what we're looking for, but we know that our theta, our initial angle, is 30 degrees. So as far as y's go, we have a delta y peak to ground, we have a v initial y, we're assuming time y, and we're going to assume this is a ground to ground, so that means that our y time is half of our x, our gravity is negative 9.81, and then we're going to have a v final in the y direction. So we are assuming, like I said, ground to ground, so that means that all of the things on the y side are going to be relatively easy to find, and then we can use that information if we need it. So we're trying to find the overall initial velocity. So given the fact that we know 2 of the 3 x values, we're going to use delta x as vx tx to figure out what our x velocity is. So that's going to be 28.6 times v, or equal to vx times 1.84. So solving, we get a velocity in the x direction of 15.54 meters per second. So looking at the values for v initial, what we're trying to figure out is the overall, which as far as our vector addition goes, that's going to be our hypotenuse. So we have a v initial of a certain value, we have an angle, and we have different components. So we're going to have our v initial in the x direction, which is running horizontally, and then we'll have our v initial in the y direction, which is running vertically. Now as far as this problem goes, we're just trying to find the overall v initial. So looking at our triangle in our diagram, we know 2 of the 3 sides and we know the angle, so we don't need the other one. We can use cosine because we know adjacent and hypotenuse. So plugging in, we get the cosine of 30 degrees is going to be adjacent, which is VOX, over hypotenuse, which is V initial. So we want to solve for V initial, so that involves rearranging. So we just exchange the position of V initial and the cosine 30. So that's going to end up giving us our value 15.54 divided by the cosine of 30 to get our overall V initial, which is going to end up being a value of 17.95 meters per second. So overall, in order to find the initial, we didn't have to do anything on the y side. We can just stop right there and be done overall with the problem.